You can create a dataset with clusters, a dataset that contains decision boundaries which can be used for classification. Did the same thing with multiple layers, creating an imbalanced dataset with fine-tuning the parameters. All this with just Scikit-Learn. Let's get into it. So let's start with creating a dataset of clusters which can be used for clustering. And we can just simply do this by using the makeBlobs function. So from Scikit-Learn.datasets, we want to import the makeBlobs function, and then we will import matplotlib to visualize the data. Now to create this, we want to first directly create the X label and the Y label, and then use the makeBlobs function that we imported. Inside this, we first mention the n samples. Let's say I want 200 samples. And then you have to mention centers, which indicates the number of clusters that we want. Also, I will mention the random state to be 42. Now that's it. We have created a dataset that contains 4 clusters and 200 samples. In order to visualize this, let's just use matplotlib. And when you run this code, you get to see a dataset of 4 clusters. You can also mention the centers to be, let's say, 6, and you get 6 clusters. And similarly, you can just set the complexity as you wish. Now there is another function in Scikit-Learn which can be used to create a dataset that has curves, and this can be used for, let's say, a polynomial regression model, or you can use this to test a specific part of a neural network. And in order to create this, what you can do is actually import the makeMoons function, and then you'll also import matplotlib. And the way you use this is similar to how we did it before. You use the makeMoons function, and then inside this you first mention the number of samples, and then you also mention the noise. That's about it. You can just visualize this and see how it is. And naturally, without any fine-tuning, you will get to see a dataset that looks like this, where there is a set of curves, and you can just use a specific curve if you wish to test a model on that, on how is it performing with the turns and the curves and the trends. Now, you can create a classification dataset in terms of decision boundaries by using the makeCircles function from Scikit-Learn. Again, you have to import that from Scikit-Learn.datasets. And after doing this, you again just simply call the functions and then mention the number of samples, that is the number of records that you want, and also the noise. Now, when you plot this, it's going to be using this plt.scatter function. And then when you see this color, I have set this to Y circles. This just means that the specific cluster will be assigned a specific color based upon looking at the Y array, that is the actual output label array. And then we have set the size to 50 if you don't understand what S means. Now, when you run this, and there you go, you get a classification dataset where you have to apply a decision boundary, and one that is above that is termed with a different color than the one that is inside that. And there is another function in Scikit-Learn that can be used to generate a dataset that requires more number of decision boundaries to attain more number of segmentation. And this is called the make Gaussian quantiles. I have imported that from Scikit-Learn datasets once again. The way you use this is very similar. You just mention the X and the Y label. Just call the function that you just imported like that. First, as always, you mention the n samples, that is the number of records that you want, which will be 300. And then you mention the number of features, that is the number of parameters, or the number of columns, or however you want to say it, which will be, let's say, 2. And then you mention the number of classes. This is the main clusters that you want to create. Let's say I want 4 clusters. Here we see that we get 2 of them. Now when you type this in 4, and then close it, and try to plot this, there you go, you see that you get 4 different clusters. The first one, as we go deeper inside, it is right around the center, and as we move outwards we get another cluster, then we see another cluster, and then the final cluster is spread all over. Now very often in machine learning you will encounter datasets like this where one kind of output dominates over the other kind of output, and this is known as imbalanced dataset. And you can create this type of imbalanced dataset for testing any type of model using the Scikit-Learn function make classification. Again, you want to import that from Scikit-Learn.datasets. Then I also just want to import numpy, and then the way you use this function will be x, y. Again, just call the function. For this, you first always want to mention the number of samples, which will be, let's say, 1000. And then you want to mention the number of features. As said earlier, this is the number of parameters, which will be set to 20 for my case. And then you also want to set the n informative. This decides how many of these 20 features are very informative that can be used to actually create reliable predictions. And I'm just setting that to be 2. And then you also want to mention the redundant features, and redundant will be 10. Then you also want to mention the weights, and this is the main criteria that we have to mention to create imbalanced dataset. You want to mention the one that is dominating over the other to be a significant amount, like let's say 95 to 5. Make sure you put that inside a list, and that's about it. Now, this is how you create an imbalanced synthetic dataset. Now, when you plot this by using the scatter function, run this. Oops, you want to mention this to be D, and run this. And there you go, you get very minimal amount of yellow when it's compared to the other one, the other color. And then this is considered as an imbalanced dataset, and you have to find ways to actually correct this before providing this to the model. Now, you could also use the make regression function to create regression datasets. Let me show you how.
guilty. Now again, similarly as we have done before, you just want to create the X label and the Y label, and then call the function that we just imported, make regression. Inside this, as always, you first mention the n samples. Let's say we want 100 samples. Follow that with the number of features that we want. I'm going to have this to be just 1 for simplicity. And then you also get to mention the noise parameter. Let's just have this to be 0.1 for now. And when we plot this, you get to see a graph that is fairly a very straight line. Now, if you don't want this, if you want to have a bit more noise, then what you can actually do is simply increase the noise parameter. And there's another way which involves NumPy. So I'm just going to import that, import NumPy. And what you could do is create a deviation parameter like that, and have this to be using the NumPy random.normal. Then you first mention the location. Now this function will create some set of values. The size has to be mentioned, some set of values. Those numbers are just a small number above the location that we just mentioned. And here I'm just going to have this to be 0. And then you also have to mention the scale. Now this will decide the standard deviation of the entire set that is created. So if you want to have a small deviation from the location that you actually mentioned, then you want to have the scale to be as small. I'm just going to have this to be 10 for simplicity. And then you also have to mention the size. This is actually going to be our Y label size. So I'm just going to have this to be y.shape of 0, like that. And then what you can do is create another variable, y with deviation, and then add the deviation array that we just created to the actual Y label, y plus deviation, like that. And then you can plot the y with deviation like that under this code cell. And there you go, you get a graph this time with a lot of scattered values, a lot of noise, and a lot of deviation.